Hey everybody. I wanted to go over some useful technology. What we've been doing lately is interfacing with the Monica CRM. The Monica CRM has a nice REST API with a lot of good features to it. For our current project, I've needed to build quite a few little scripts that interface with this API. These are small scripts. They serve very narrow function. I chose a few techniques that enabled me to develop these quickly and incrementally. And I figure we would go over these technologies and techniques while building a script for the Monica CRM. One is the Ammonite.io system, and the other is using Scala streams to query paginated content. Ammonite.io is a scripting environment for Scala that includes a bunch of built-in functionality that is quite useful to have. This is actually an inspiration for our own product, including quite a lot in its distribution to enable you to quickly get started developing services. Right now we're going to talk about the Monica API and how we can quickly interface with REST APIs using Ammonite. The Monica API, like I mentioned, has quite a nice set of features. It is nicely documented, likes to include extended error information as a nice JSON structure, uses bearer authentication, and has a consistent pagination system. There's a lot of different ways to represent unbounded result streams. Pagination is one way. Depending on your application, one way might be better than another. Pagination, though, is very common due to the ease in which it maps to individual pages of results in a web interface. And that's a very common idiom, or I guess you'd say a pattern, that we encounter and get requested when developing web interfaces. I've already typed out the initial structure for this. I attempted originally to record this development and then do a voiceover after the fact, but that takes an exorbitantly long time. We're going to do the audio while I am typing. The unfortunate thing is that there's going to be some clicky-clacky noises as I type. I highly recommend watching this video at 1.5 to 2x speed. I think that gives better pacing than the actual pace at which I wrote this. The structure in which I'm developing this is utilizing two aspects of Ammonite. One is the AMM entry point or launcher, and that is also the pre-def and watch options to that. Pre-def lets us add essentially what amounts to a custom prelude to everything as we compile it, which saves me some import typing, and watch has it rerun the given script every time the project files change. Let's see what that looks like. So if we look at our script here, we have our interpreter declaration here, which we're saying Ammonite again with the pre-def. That just lets us run it directly outside of this watch mode. And we see an file import for Monica queries. That lets us separate out all the queries that we're making to Monica into a separate module. And we see the main that we're going to be running. For this script, the goal is to list all the relationship types in a Monica CRM instance. And I just want to print them to the console. And we see here, this is performing a query, relationship types. And for all the relationship type instances in that result set, it's going to print the name and IND. Make this a bit more explicit, like so. If we look at that query, we see that it is unimplemented. And that's where we get this "an implementation is missing" aspect. Even to get here, I've added some initial data structures that represent the data as provided by Monica in JSON that I'm interested in. The goal is to have a stream of relationship type structures. These relationship type structures have a name and an ID. there's actually more to relationship types than just name and ID. Here we're at the documentation showing the full API get relationship types, and we see that it returns a structure with a data attribute that is an array of relationship types. And if we go further down, we see some metadata for pagination. You can see these relationship type structures have a lot more than ID and name, but for the purpose of this application, I'm only interested in ID and name. One aspect about these data structures that may seem odd is that I'm using underscores for the names here, and that is to be consistent with the Monica API that also uses underscore. We're going to use uPickle's automatic generation of readers and writers for JSON, and for that, having the same naming convention is useful. So we have our relationship type that we're interested in, and we have two other structures here, page meta and relationship types page. When developing these type of scripts, I try not to model more than I need to at first. I just capture exactly the data as provided and only the data that I'm interested in. That's why there's this specific relationship types page structure that has this data attribute that is a listed relationship type and a metadata. There's other ways I could have done this, such as making a parameterized type, because this paginated pattern is used several times, and I will leave that complexity to a later time. Back to our relationship types query. For starters, let's just get the first page, and for this I'm starting very explicitly with another query. We're going to use the Ammonite included library requests to perform these requests, and then uPickle to parse the JSON. I've already imported the Ammonite ops libraries via this predef. Ammonite ops, I've also included mutable collections and sysprocess, which I like to include in all my Ammonite scripts. So request is already in context here. And what do we want from the resource? Well, we want a response. Let's start with that. And let's get our /relationship types from our base URL. What is our base URL? That's going to be kind of hidden in this actual code. To load this in, we're just going to read it from a secrets directory, which is relative to our current directory, and then trim that file. This file is stored in a, what you want to call it, encrypted mount, and contains that particular secret. Another one, of course, is the bearer token, which we're going to read from the same secrets directory. These trims just remove the new lines, so we don't have to worry about them. This gives us our bearer authorization header, which we're going to also include in our predef, so I don't need to repeat it again. So we have loading in our base URL and our bearer token, and then combining that to be our authorization header. And sure enough, we get back to our Ammonite watch, and you notice that this entire time while we've been editing, it's been reloading and rerunning everything. If you were building a script that manipulated data, this might be a bit concerning, but in this case, we're only working with queries, so that is totally fine. We're just going to have it repeat over and over until it starts spitting out the data that we want. And we noticed that it couldn't find base URL, but that's fine because then we eventually implemented it. Now we notice that it's getting all the way to get relationship types first page, question mark, question mark, question mark, which is right here. Okay, so it did perform this query to response. What was the response? Well, let's check it out. Response.text. And we see an HTML response. Let's see if we find, and it requests this to log in. And this makes sense. We haven't included our authorization header, and we haven't specified that we want the JSON result type. For our headers, well, we have an authorization header, which we will now provide. And we see how it has started to return the results in JSON. We didn't need to specify the accepted response type, as this is the only representation for this resource. But if there were multiple representations, which can be the case for a REST API, it could have an HTML representation as well. We would want to add an additional header here that specified our expected response type. But for this, we're good to go. Now we're getting back a JSON response containing the data that we want. However, this is just the text. We haven't actually parsed the JSON, and we certainly haven't parsed it into our expected result type. So let's do that now. As I mentioned before, we would be using uPickle for this. uPickle for JSON has an interesting aspect where it uses empty lists to represent missing attribute values. We want to use option. To get that to work out, I'm going to introduce a new JSON pickler that is going to be specific to this aspect of Monica. This is a bit of boilerplate. And what I'm doing is stating that how options are read and written is not the default way, but we're going to override it with a new way that represents nulls explicitly. This is largely from the uPickle website. So let's not worry too much about this code. It just gives us nulls as I expect them to be, or more accurate, or as Monica expects them to be. And once we've written this bit of boilerplate, we don't really have to worry about it again. But it does demonstrate something that I like, which is the ability to have a structure with a bunch of implicits and then actually override those if you want a different behavior for your application. All right, let's hit go there, and we see it did in fact compile, and we're reaching the same point once again. This live feedback, very useful. Give us compilation results right off the bat, and show us our results. So now we have this JSON pickler. The bit we want from this JSON pickler is not just this object JSON pickler, which contains read and write. First is a trait, actually, called readWriter, which I'm going to name as JSON RW. And then there's also a macro called macro readWriter, which I'm just going to name auto JSON readWriter. I think these are a bit clearer names. They're very explicit that we're talking about automatically generating a JSON readWriter, and that this is the type of JSON readWriters. And if we go back to our model here, we have these types. And these are the types that we want JSON representations for. So, starting with the top one, we're going to say that this has a readWriter, JSON readWriter, that is of type JSON RW. And this is automatically derived. And likewise, we're going to do the same for page meta and relationship types page. One thing while I'm typing this is I've always wanted a machine learning algorithm that operate over this audio to filter out all the typing noises. I'm sure a principled non-ML algorithm could be made, but you could probably just train a machine learning algorithm to do the filtering better without as much explicit effort. That'd be nice to have. Maybe we'll talk about that some other day, but that's outside of my domain, really. Now we have all these JSON read and writers for all the structures that we need. We can see it still compiles and we're still hitting implementation missing. That's fine. Right, now we are ready to parse that JSON. Read using our JSON pickler a relationship types page from response.text. And we'll see how this compiles. Ooh, would you look at that? And we're going to go ahead and print this first page as it is represented in Scala, and we can see that we did in fact parse and get all the data that we wanted. We have a relationship types page, which contains a list of relationship types, which contains our names and IDs. And additionally, we have some page metadata information, 1 to 27. Okay, that's good so far. Not too much, not too bad. Obviously, though, we want to iterate over these pages because we want this stream structure. But what is that going to look like? Well, we start on the first page and we iterate until the last page. We actually want our method getRelationshipTypesPage to take an optional argument, which is the page. And I'm going to make this an option just so the first query is exactly equivalent to not providing a getParam. Then we are going to actually add the getParam. So far, this should do exactly the same. Not enough arguments for the page. Oh yeah, sorry. We need to actually make it optional. And sure enough, we have an implementation is missing, which means everything is compiling and we're still getting the first page just fine. All right, so what is those pages going to look like? Well, that's going to change our URL to have a getParam. And we're just going to make a value here called path. And that is going to take the page. And if it's no page, it's going to be exactly types. And if there is some page, we are going to query for relationship types page equals page index. And now instead of base URL plus that fixed path, we're going to give it this dynamic path. And we see we're still running, but is it working as we expect? Well, let's try getting some page 2. And indeed, we note that we got back page 2, and now we are actually on the final page 2 of 2. Right, so now we have all the components necessary to return a stream of relationship type structures. We're going to get our first page, which is going to represent the start of the stream and contain the information we need to get the next page. The next page is going to be interesting because it's going to take the current page, which is a relationship types page, and it's going to return a stream of relationship type, just the same as we had it, except we're going to call it as the next step in this relationship types query. These types check out. As we can see, it compiles, and now we're just left with implementing this. Well, what determines if we are done with the stream or not done with the stream? And if we check at our Monica model, we find in our page meta, we have current page and last page. We are done and no longer need to requery if current page equals last page. So then if current meta current page equals current.meta last page, then we've queried the last page. And the rest of the stream is the current data to stream. It's already a list. If we look at our Monica model, we see that our relationship types page data is a list, and we just want to stream. So we're just going to say we're going to take that data and we're going to make it a stream. If it isn't, and actually let me not name this next, but let's name it go. Oops. If it isn't the last page, then we do want to query the next page, which is going to be get relationship types page sum current.meta current page plus 1. Right, we just want to get the next page. And now that we have the next page, we're going to go again on the next page as the continuation of our stream after we do get current data to stream again. Ooh, to stream, no, to Steam. 2, 3. And we're going to append that to whatever's next. There's a few other ways to structure this loop here, but they all end up doing basically the same thing. Let's zoom out a wee bit. And we see we are listing the relationships right. We'll get back to that in just a second. What we did here is introduce a inner method that's recursive, but the control flow goes through stream and it's suspended as part of the next part of the stream. That's what's happening right here. We get the first page, and the first page array of data we're converting to a stream and providing as the next chunk of the stream. And then we're saying it's appended to the next of the stream right here. This chunk isn't actually evaluated until we reach that part of the stream, at which point control flow goes back into this method and starts back with go, which then does this loop again. This is why we can write this very convenient loop that is very, I think, representative of how you think of iterating through a page, provide a stream, and in our script here, we are iterating through that stream as if we would iterate through any other collection. The aspect that there is a sequence of requests and there's actually a delay evaluation for those requests until they're required is hidden behind the stream construct. And sure enough, when this is run, we see that it is printing out all relationship types. And if you noticed earlier, it was only doing 10 per page. And we know the streaming aspect is working because we've seen more than 10 here. And in fact, we see 27 total, which is quite right. Oh, actually, sorry, it was 15 per page, not 10, I think. Well, either way, we see that it's working just fine. It's still watching for changes, but we're done here. And now we want to verify that this script works out by itself outside of the Ammonite launcher. To do that, we make it executable. And then we should just be able to run it just like any other script, just like so. Oh, sorry, I got this entry point slightly wrong. I need to put a S there. And you see, as we run it, it compiles it, then it runs the listing. But if we do it again, there's no compile again, and it just runs. Pretty nice, huh? This is a very nice set of techniques, I think, for building scripts that work with REST APIs nice and quickly, nice iterative fashion. And you can end up building upon your models, your queries, and your commands and your scripts to end up with a very handy tool chest using only what's provided in the Ammonite Scala scripting system. I hope you found this useful. And if you want to support this channel, there's the usual methods: like and subscribe, Patreon, and all that. If you really want to help support making more of these videos, I'd love to talk with you about your projects. I definitely like seeing small business services and seeing how we can evolve those at my company, Dogheadbone LLC. Give me a message if that sounds interesting to you. Till then, I hope you have a good day.